Hey everybody, how's it going? This is Damian Carlson with the ProfessionalVMware.com weekly Wednesday brown bag. As you guys are probably aware, tonight is Section 2, Networking. We're going to be featuring the Scott Lowe, and I'm really, really excited that Scott has had the opportunity to join us. Before I kind of hand it over to Scott, I've got a few quick notes. Last week, at the suggestion of a few folks like Josh Atwell and a few others, I ended up starting a Twitter list. So you can follow that Twitter list at 6footdad/brownbag. That's kind of a living Twitter list as it is for folks who regularly attend the brown bag, and it's an easy follow if you're new to the community. Feel free to follow that to kind of get a peek into what's going in and around the VMware virtualization community. If you want to talk about it on Twitter, our hashtag is brownbag. Pretty simple. I've got a few things here. If you want to check us out on iTunes, easy link is bit.ly/brownbag iTunes. And then if you just want to subscribe to the podcast, or you have some other sort of podcast catcher, whether it's Stitcher or something else, feel free to check us out. Our feed burner feed is actually at bit.ly/brownbag podcast. And again, my name is Damian Carlson. I'm at 6footdad on the Twitters, and I've got Scott Lowe this evening. He is at Scott_Lowe. And I think before I hand it over to Scott, as everyone knows, if you're if you've been in more than one of these brown bags, you know by now that if you would like to participate in the conversation, or if you have any questions or anything else, feel free to send me a question through the questions pane within the GoToWebinar interface, as well as if you'd like to be unmuted or something like that, feel free to raise your hand within the GoToWebinar interface. I'll get you unmuted, and we can have a great discussion here. GoToWebinar mutes by default whenever you join a webinar, so rather than unmuting everyone who may not want to be unmuted, or whatever else, I just think it's easier to leave everybody muted, and it's kind of an opt-in thing. So pop us a question, raise your hand, and I will do my best to facilitate the discussion as Scott starts going through his presentation. So, Mr. Scott Lowe, I turn it over to you if you'd like to go ahead and introduce yourself.
Thanks, Damien. Appreciate it. Can you guys hear me okay?
I can hear you just fine, and I am not seeing any other questions from any other folks.
All right. Well, then we'll take their silence as indication that everything's going all right. So thanks for the opportunity to come on. I hope to be able to share some useful information. Damien, kind of already introduced me, but just some background. If you aren't familiar with who I am, I've been in the VMware virtualization space for quite a few years now. Like a lot of people, I have my own blog, which is easy to find. It's just my name, scottlowe.org. And on Twitter, as you can see there, at Scott_Lowe. I've written a few books, the Mastering VMware vSphere series, vSphere 4 and vSphere 5, now available as well. And just love to support the community, love to help out and share information. That's why I do what I do. And so I'm excited to have another opportunity to do it here. All right. And I guess, Damien, you need to transfer presenter over to me. Is that right?
Sir. Yes, sir.
All right.
And there you go. I just turned it over to you, so you should see that popping up here shortly.
Okay. All right. Well, it says it's showing my screen, so can you guys see anything here?
I am still seeing the let's see. I'm still seeing the waiting room.
Okay. Let's try that again.
There we go.
Okay. So I won't bother going into presentation mode. We can just flip through this. What I've got here is we're going to be covering section 2 of the VCP5 blueprint, which is all around vSphere networking. So what I've done just to provide some structure around the discussion is just create a real simple, you can see real simple 3D slide for including the title deck here, the objectives, and we'll just walk through the objectives. I'll add additional information. I didn't want to create some sort of huge, gigantic deck that would just pull in information that already exists elsewhere. Instead, we'll just point you to where the information exists and where you can get it. And that way, you know, we're not duplicating effort with documents that have already been written and so on and so forth. So with that in mind, if you're ready, we'll go ahead and get started with talking about vSphere networking. Networking is one of my favorite subjects, which I guess works out well seeing as how I'm talking about it tonight, doesn't it? All right.
Absolutely.
All right, so networking. We've got 3 objectives. If you're looking at the blueprint, I've got the blueprint pulled up on another screen on a separate computer, just so we can walk through that as well. If you look at the blueprint, Section 2 has 3 objectives. The first objective is talking about vNetwork standard switches. Everybody likes to call them V-switches because that's a lot easier to remember than a vNetwork standard switch or a VSS, because as we all know, VSS has a lot of other meanings in other contexts as well. The key objectives here are pretty straightforward. We want to be able to identify the capabilities of a vNetwork standard switch, create, delete them, add, remove, configure VM NICs, configure your VM kernel ports, add, remove port groups on a vNetwork standard switch, and then determine the use case. So let's delve into a little bit of these, each of these in a little bit more detail. Capabilities of a vNetwork standard switch. Now here I'm going to rely on the audience to tell me how deep we need to go in terms of some broader networking sort of functionality. Because we can talk about the vNetwork standard switch capabilities and say, oh, well, you know, a vNetwork standard switch does this, or it does this, or it does this. But if we don't have a clear idea of what that means in a broader networking context, then it may not really be a whole lot of value. So be sure, if you're out there and you're listening, and then you have a question as I go through this, be sure and just note that, or request to be unmuted so that you can ask, and then that way we can make sure we have the right level of information. So what can we do with a vNetwork standard switch? Well, quite obviously, and probably doesn't need to be stated, but the vNetwork standard switch is the basis whereby we provide all network connectivity to virtual machines, whether that be network connectivity to other VMs or whether it be network connectivity out to the physical network. It's not this, it doesn't behave the same way as a standard switch, a physical switch. So there are some differences between what and you're going to see some things pop up on my screen real quick here while I activate this to keep my screen from going to sleep. Okay. There's certain things that a vNetwork standard switch won't do that a physical switch does do. So if you've been in the networking space and you say, oh, okay, well, if this is a switch, then it behaves the same way as a physical switch. That's not entirely accurate. So you want to make sure that you understand that, for example, it won't forward traffic back out that it receives on an uplink. Okay, an uplink being a physical NIC that we've assigned to the vNetwork standard switch that connects it out to the physical world. A physical switch, when it receives traffic in on an interface, then its whole job is to forward that stuff back out another interface to the destination system, whether that be virtual or physical or whatever the case may be. A vNetwork standard switch can receive traffic on an uplink, but when it receives traffic on that uplink, it will only send it to a VM if there is a VM to which that traffic is being directed, or it will discard it. It will never forward it back out. And so this is why, for example, when you look at the recommendations for setting up a vSwitch, they tell you that you don't need to run spanning tree or STP, spanning tree protocol, on ports that are connected to a vSwitch. And that's because a vSwitch would never forward traffic back out and therefore would not create a bridging loop, which is the whole purpose of what spanning tree is designed to protect against, is the creation of bridging loops. So there are some subtle differences there, and a lot of that stuff is explained in the documentation, so I'll refer you to the vSphere networking guide, which will go into that in a lot more detail. Of course, we have full support for VLAN tagging via 802.1q. That means not only can we pass VLAN tags up into the vNetwork standard switch, we can also pass them all the way up to the guest. And the trick for doing that in a vNetwork standard switch is different than the trick you use in a vNetwork distributed switch, which we'll see in the next section. But in a vNetwork standard switch, you actually assign the VLAN ID of 4095. And because that sits outside the legally allowed range, because the legally allowed range of VLAN IDs is 1 through 4094, when you put in 4095, that's a signal to vSphere. I want to take these VLAN tags and I want to pass them all the way up to the guest. At that point, you have to have a guest that is configured, a guest operating system that is configured and capable of understanding the VLAN tags and then going from there. So Windows does this. A lot of Unix variations do this. Not terribly common, but still supported if that's something you want to do. A couple different policies. Yeah, go ahead, Scott.
I've got a question coming in via Twitter from Gabriel Chapman. His question is, when will support for LACP be provided, aggregation instead of just Ether channel? I think I know the answer to that one, but I'll go ahead and let you address that.
Okay, so you want to know about LACP rather than just standard, Ether channel. There's on the vNetwork standard, there's no support for LACP currently, even in the V5 release. It may be on the roadmap for a future release. I can't really comment on that. The real question would be, though,
are we talking about static LACP or dynamic LACP?
Well, we could. So that's the subject of some debate. Some people would say that if you are calling it static LACP, it's not LACP, because LACP by its very nature is intended to be dynamic.
Gotcha.
So, it just depends on who you're talking to at that particular moment as to whether or not they agree with the idea of static LACP. You can certainly do link aggregation today, and while we call that Ether channel, it is supported across a number of platforms, not just Cisco's platform. So, I've worked with HP ProCurve switches that allow us to create link aggregates, static link aggregates, using the equivalent of Ether channel against a vSphere host. So we say it's Ether channel. It's link aggregation. It's just not dynamic link aggregation. So it doesn't support PAGP, which is Cisco's old proprietary protocol of doing dynamic link aggregation, and it doesn't support LACP, which is the standardized form of doing dynamic link aggregation. But you can do static link aggregation just by defining it on the vSwitch and then defining it on the physical switch to which it connects.
Okay.
And so I'd like to come back to that idea of link aggregation a little bit, because I think that's a good topic to talk about, to really understand when it would be beneficial to use link aggregation versus when it's not. Yeah. Damien, you picking up that echo as well?
Yeah, I am. I muted Shane. Shane, can you take us off of the speaker, please?
Oh, yeah, hold on.
All right. So capabilities for a vNetwork standard switch. We talked about VLAN tagging. We can do link aggregation. We have a couple different failover policies that we can set for uplinks. It supports multiple uplinks. The specific number of multiple uplinks is in the configuration maximums guide and in the other documentation, so I won't bother going through that kind of stuff here, but you will want to be familiar with how many uplinks we can put on a vNetwork standard switch, how many ports we can put on a vNetwork standard switch, that sort of thing. You can adjust the total number of ports available on a vNetwork standard switch through both the command line as well as the vSphere client. The key thing to remember, and one of the key distinctions between a vNetwork standard switch and a vNetwork distributed switch, is that the vNetwork standard switch is essentially managed on a per host basis. So if you have a change that you need to make across multiple hosts, it has to be done on each host. Now, we all recognize that you can work around that by creating PowerShell scripts or Perl scripts to do that in an automated fashion for you, but the reality is that it's under the covers, it's still going and doing it individually on every host. Of course, we could also use host profiles out of vCenter server and the vSphere client to help automate some of that configuration for us as well. But again, under the covers, those vNetwork standard switches are being maintained and configured on a per host basis.
Okay. I've got a couple quick questions here, Scott. Shane Williford wants to know if you plan on touching on migrating from a distributed switch with a single physical NIC back to a standard switch.
Can I repeat that again?
Do you plan on touching on migrations from a distributed switch with a single physical NIC back to a standard switch?
Yes.
Okay. And then, okay, so Shane, that's your question. Richard Powers had another question. Isn't the port range 0 to 4096 for VLANs? He thought you said 4094.
Right. Technically, we use a 12-bit value, which would give us 4,096 different combinations. But if you go to just about any networking vendor, they will max out at 4094 or less. So if you go into a Cisco switch, for example, it typically would not allow you to create a VLAN with an ID of 4095 or 4096. And like, so it's one of those things that just, yeah, it's a 12-bit value, and yes, that technically gives us 4,096 different values. We really only can assign IDs from 1 to 4094, and depending on the switch, sometimes less than that.
I didn't know that. Thank you, Scott. And Richard, I hope that answers your question. He says that it does. All right, so go ahead, Scott.
All right, and I'm seeing a question here from Steve Beaver, too, about IP hash with LACP. We're going to talk about the load balancing policies in a little bit, but yes, the load balancing policy that you would use with link aggregation is the route based on IP hash, and we'll talk about that because I'd like to help everybody understand. I think a lot of people get caught in the IP hash is the best way to go, and that's not necessarily the case. So I do want to talk about that a little bit. So we'll do that a little bit later on in the webinar. Okay. So I think that pretty much wraps up the capabilities. You can do some limited outbound traffic shaping on a vNetwork standard switch. That's configurable as well. We'll talk about the policies for failover a little bit later on as we move through. Just flipping through my notes here to see if there's anything else we're going to mention. We already mentioned VLANs and the ability to support. Now, there's 3 different types of VLAN configurations, and we'll see this again when we do the vNetwork distributed switch. You can do an access port where there is no VLAN tag being passed up to the vSwitch. The VLAN is being controlled at the physical switch layer. We can do a trunk port, which is very common, and that's where we pass some range of VLAN tags into the vSwitch, and then we can do virtual guest tagging, which is where we use that value of 4095 to pass the VLAN tags all the way up into the guest operating system. And we'll see the way you do that on the vNetwork standard switch is done one way. It's just by specifying the VLAN ID. So you leave the VLAN ID blank if you need an access port. You put in the value if you want to trunk, if you want it to trunk up, or you use 4095. The way you do that in a vNetwork distributed switch is actually a bit different, so that's kind of interesting. We'll look at that in a moment. So there's a couple of different other things. Again, we have to mention that you have to assign physical NICs or VM NICs to the vNetwork switch. We'll look at that process in just a moment. There's some security policies that you can set on a switch. For example, will it allow promiscuous mode, the ability to listen to all the traffic that's on the virtual wire, and those can be set in various ways. So those are some of the policies that you want to look at on a vNetwork standard switch. The process for creating or deleting a vNetwork standard switch is pretty straightforward. You can do it inside the vSphere client from the configuration tab, and then select networking out of the upper box. I believe that's the hardware section. And then from there, you'll see you'll have 2 views. You can switch, if you're using vCenter server, so again, you're connecting the vSphere client directly to the vCenter server, you can look at a vNetwork standard switch or a vNetwork distributed switch. In the vNetwork standard switch view, you'll have the ability to create additional vSwitches, delete vSwitches, modify vSwitches, all that kind of stuff. You can also, from the command line, you can create vSwitches, generally done using the vSphere Management Assistant or the VMA. And that is done using the command vi-config-vSwitch. Okay, so vi-config dash vSwitch, and then there's a set of parameters you would pass out to that would specify depending on how your VMA is configured, you might need to specify the vCenter server you're going to connect to, the host you're going to perform the operation on, your username, your password. Again, that all depends on your VMA configuration, which I'm sure you'll go into much more detail if you haven't already in another podcast. But if you're a command line junkie, and I am, then using command line is also a way to not only create but also to remove vNetwork standard switches. Some people would prefer to use the vSphere client, and that's fine. No big deal. Also, same place inside the vSphere client is where we would add, configure, or remove the VM NICs. And the VM NICs are the physical NICs that the host has discovered. Okay. Now, a couple different things here. There's a lot of technologies out there that will adjust the way this works. So you have to be careful of how you make the association between VM NIC and physical NICs, because there's a couple of key technologies that I'll mention that could come into play. You probably won't get asked about this on the exam, but looking past the exams, actually using this stuff in the real world, HP has a solution called Virtual Connect, and they have some pieces of that Virtual Connect called Flex 10 that allows you the ability to subdivide a physical NIC into multiple logical NICs. And the reason I mention that is because each of those logical NICs will appear as a VM NIC, a separate independent VM NIC. So as you're designing that, you'll say, oh, okay, well, I've subdivided this Flex 10 device into 4 logical NICs, and then I can just break the traffic down, and that way I'm guaranteed that these traffic types aren't going to commingle with each other. That's not exactly accurate, because they're going to come down and they're going to collapse onto the same physical NIC and go across the same physical uplinks to the rest of the network. So that's just giving you a logical distinction. Same is true inside Cisco UCS. If you've looked at UCS, they have this virtual interface controller, or VIC card, which allows it itself to be subdivided into logical NICs. So just understand that difference, and be sure that you are aware of how the NICs relate to actual physical NICs or logical NICs when you're planning your assignment out. But adding and removing VM NICs to a vNetwork standard switch is all done, again, inside the vSphere client. You pull up the properties for a vNetwork standard switch, and then you have the ability to go to the Network Adapters tab and add a VM NIC to the vSwitch as an uplink, or to remove. And then as far as configuration goes, you can configure the NICs to specify, am I going to control a speed, a duplex setting, anything of that nature. Generally speaking, you'll leave that stuff at auto unless you have a good reason to change it otherwise. So, I see a couple of questions showing up in here.
There we go. Yeah, I was just going to direct you to the questions, but you're already on top of it.
Well, I can see these, and I can't look at these and follow Twitter at the same time. Sorry. I'll let you follow Twitter.
Yes, sir. Yes, sir. I'm actually trying to do all of them, and yeah, it's
okay.
Fun.
Well, you see, you're a man of many talents. What can I say? So Matt Malewski had a question about port group tagging. We are going to talk about port groups here in just a moment, so hopefully that will address whatever question you have there, Matt. Tim had a question here about vSwitches. Is there any way to VLAN hop from a different vSwitch? So I guess the question would be that if you have a VLAN configured, and would there be some way for traffic to jump from one VLAN to another VLAN? It used to be much more common. They had a couple of different ways, and usually it was around the use of something we call the native VLAN. And so here's where things could get weird if you're not relatively grounded inside networking. The native VLAN is a VLAN that the switch assumes that it won't be tagged. Therefore, it doesn't add an 802.1q tag frame that they pass through. It just says, oh, well, if it's untagged, we're going to associate it to this native VLAN, right? And so there used to be tricks that you could play where you could double encapsulate a frame, one with a native VLAN and another one with another VLAN ID, and then that would enable you to do a sort of VLAN hop on the physical side. Now, all the switch vendors addressed that sort of double encapsulation hole So the idea of VLAN hopping, there's probably some security gurus out there that know how to do it and know how to make it work, but it's a lot less common. And from a security perspective, if you want to know, is it safe for me to use VLANs as a means of providing traffic segregation, that's really going to depend on your security group and your auditors. Some organizations and some industries will accept VLANs as a way of separating security zones. Other organizations and other industries will require that they have physical separation, physically separate NICs, physically separate switches, physically separate wiring. So, for the most part, VLAN hopping is fairly difficult to accomplish. There are no known vulnerabilities in the vSwitch code that would allow somebody to VLAN hop. There's also no known vulnerabilities in the vSwitch code that would allow somebody to escape out of the vSwitch or to communicate between two vSwitches. It's important to note that two vSwitches on the same host, unless you go through and connect them, will never be able to communicate with each other. So a user will actually have to do something.
That's exactly what I was asking, Scott, is I'm trying to re-architect a scenario here where we're trying, I'm proposing that I would combine sub-DMZ and DMZ clusters into one, giving each multiple physical NICs to separate physical switches in different segments of the data center. The question that security is asking is there any way that you can VLAN hop between separate vSwitches? And I haven't been able to find anything that says that there's any way to do it.
Yeah, I'm not aware of any vulnerability or any sort of workaround that would allow you to do any sort of traffic between two vSwitches, whether you VLAN hop or whether you just would switch layer 2 switching.
Oh, lost you.
Okay, my headset's acting up. Unless somebody goes and actually physically cables us up.
Okay, so I'm fairly confident in my stance then that as long as we're going into separate physical NICs, separate switches, firewalls, everything between everything, that their stance was just the fact that it would coexist on the same physical cluster. They think that it's going to commingle, and it's not going to happen.
Right. Like I said, there's from all the security gurus that I've talked to and all that, nobody knows of any vulnerability that would allow that traffic to cross between the vSwitches. So as long as you're taking best practices into consideration and applying appropriate change management, then you should be good to go.
Great. Thank you.
Yeah, no worries at all. All right. So let me see. Josh has a question here. DoD said they did not have issues with VLAN hopping, so that's important to point out that it's not really an issue here. Of course, at the same time, a lot of the DoD enforces an air gap, so even though they don't have an issue with VLAN hopping, they also don't allow you to commingle traffic on the same physical network. So maybe that's why they don't have issues with VLAN hopping. All right, adding, configuring, removing VM NICs, I think we've got that pretty much covered. Again, be sure that as you're designing the solution, and again, this then goes beyond the exam objectives, but make sure you understand the logical and physical architecture that you're talking about here, that you want to find VM NICs to your switches so that you don't, if you're looking for some sort of traffic separation, make sure you know where the traffic is going. Now, there's essentially two different kind of things, and I guess maybe you could say three, that we look at when we look at a vNetwork standard switch. We have port groups, which we're going to talk about in a moment, and then we have VM kernel ports. VM kernel ports are what you would use to provide network services. So ESXi management travels over a VM kernel port. Most of you, if you're plugged into the community, probably recently saw that there's potential concern with enabling jumbo frames on your management interfaces. Duncan pointed that out, so just keep that in mind. We're going to talk about jumbo frames a little later on, but I don't have time. But you'll use VM kernel ports to provide management access. So when you install ESXi, it will create a VM kernel port by default. It'll create a vSwitch. It'll create a VM kernel port on that vSwitch, and it'll attach that VM kernel port for management so that you can communicate with it. You also use a VM kernel port for vMotion. You use a VM kernel port for fault tolerance. You use a VM kernel port for iSCSI traffic out of the hypervisor, which is distinct and separate from iSCSI traffic that you might initiate inside the guest OS, which would not be handled by a VM kernel port. So when you configure VM kernel ports, you add the VM kernel port to a switch, or you can configure or remove it. Every VM kernel port requires an IP address. VM kernel ports are also used if you're using the software FCOE initiator that comes in vSphere 5. And even though those would not leverage an IP address, they also have to have an IP address assigned, even though FCOE doesn't leverage IP for some communication. So you have to have an IP address, you have to have a subnet mask, and then it sets a VM kernel default gateway that handles the routing for the VM kernel itself. And then you can also set any sort of VLAN IDs or anything else of that you need so that the VM kernel port can communicate across the network correctly. If you need network connectivity on a VM kernel port, you can go into the DCUI on an ESXi host and check for management connectivity. If you enable SSH access to the ESXi host, you should also be able to use the VMK ping command to test connectivity across a specific VM kernel network. I am not aware, and feel free to jump in if anyone does know, whether there is a VMK ping equivalent inside the PK. If anybody knows, speak up in the questions, or just speak up.
Hey, Scott. Just want to let you know that you're breaking up a little bit.
Oh, sorry. It's probably my headset. Yep. Okay. I'll stay a little closer to my phone. All right. So, any other questions we need to tackle before we move on, Davey?
No, sir. I don't see any.
Okay. Very good. All right. So, port groups. We talked about the different kind of things that you're going to see on a vSwitch. VM kernel ports are one. Port groups are the other, and that's where you're going to attach your virtual machines. You're going to attach virtual machines to a port group. A port group is a simple way of saying that I'm going to create a template for an individual switch port, or an individual vSwitch port in this case, and all VMs that get attached to that port group then have the same configuration. So I can modify the configuration on the port group itself, and that will modify the configuration on all the ports that are a member of that port group. Now, VMware doesn't actually expose that sort of functionality, so you can't see in a vNetwork standard switch individual ports that are part of a port group, not easily anyway. But that's just kind of why they call it port group. It's a grouping of ports that you're going to attach VMs to, and they all share the same configuration. That configuration would be stuff like your security policy, whether or not that port group allows promiscuous mode or forwards MAC transmits. That might be your VLAN ID. Okay, so that all the ports in that port group share the same VLAN ID or the same VLAN configuration. It could be a failover policy. For example, you can mix and match failover policies. You can have one failover policy set on the switch level and a different failover policy set at a port group level. The exception here is IP hash. You can't mix IP hash with other pieces because it just doesn't work. So keep that in mind. But I could have, for example, a different failover order. For example, I could say VMNIC 0 is primary for this port group with VMNIC 1 as a secondary. And I can take the next port group and say VMNIC 1 is primary with VMNIC 0 as secondary. This is a very, very common way to put multiple traffic types on a single switch, but then provide some reasonable level of traffic separation, while still also providing redundancy. For example, if you said, I want to put management and vMotion on the same vSwitch, but I want management and vMotion not to clash with each other under normal operation, then you could set on a per port group basis, and then a VM kernel port, actually in this particular case, the different failover orders for management and for vMotion. Once you create that port group, then you'll see that that will be the mechanism whereby you'll attach the VM into the network. So you create a VM and they'll say where you want to connect the VM, and you'll select the port group, and off you go. All right. So when should we use a vNetwork standard switch? This gets into maybe some design questions. You know, when should we use a vNetwork standard switch versus a distributed? If you are not using vCenter server, for example, your only choice is a vNetwork standard switch. So that makes it kind of easy. If you aren't licensed, I believe the vNetwork distributed switch requires Enterprise Plus. So if you aren't licensed for Enterprise Plus, so you're not licensed to use the vNetwork distributed switch, then your only option is a vNetwork. If you're not licensed for vNetwork distributed, then your only choice is vNetwork standard. Other cases might be if you want a switch where you don't have any dependencies on vCenter server. Some people are concerned about the interaction between vCenter server running as a virtual machine on a vNetwork distributed switch when vCenter manages the vNetwork distributed switch whereby it maintains its network connectivity and gives a circular reference. So some people prefer to put management traffic on a vNetwork standard switch because it doesn't have that management plane dependency. So those are all cases where you might look at instances of using a vNetwork standard switch. All right, so I'll stop there and look through here a little bit. Matt points out that there's still some question about jumbo frames on the management network, so we'll have to keep a close eye on that. One thing, and we'll talk more about this when we get into the jumbo frame section, one important thing to note is that when you do jumbo frames, you have to make sure you do jumbo frames on the entire data path. So you can't just set jumbo frames in one place and not other places, because then the switches will get confused and it won't work right. So thanks for pointing that out, Matt. We'll keep a close eye on that. Rich asks, multiple VM kernel ports, can you have more than one default gateway? No, you're still only allowed one default gateway, even though it asks you for a default gateway every time you create a VM kernel port. Whatever you set, for the last VM kernel port, whatever you set becomes the one that it takes. If you do need to manipulate the VM kernel routing table, there is a command that you can use to do that, viconfig-route, if I'm not mistaken, that allows you to actually add routing entries into the VM kernel routing table. But you can't have multiple default gateways. And that actually makes sense if you think about it, because any given TCP/IP stack really only has one default gateway. Whether that's a VM kernel stack or whether that's a vMotion type, or a virtual machine get-to-OS type stack, either way, they only have one default gateway. All right, and then I guess to just clarified, Tim was mentioning if you, and I guess this is in reference to mixing management and vMotion traffic on a single vSwitch. Is that correct, Tim?
Yeah, you want to definitely make sure that you set some type of traffic shaping policy so you don't take down your vCenter environment. Yep,
that's a good point. So under normal operation, you can separate this, use this uplink unless there's a failure, and then if there is some sort of failure, then you could have multiple types of traffic running on the same physical uplink. So if there is a concern there, if your vMotion traffic, if you do a lot of vMotioning, you could potentially see an issue. I suspect it probably wouldn't be a major concern for management and vMotion, but nevertheless, do be aware of how the traffic is going to fail over in failure events, and then make sure you protect yourself appropriately. If you need to set some traffic shaping or some QoS, then do that. You can do that sometimes at the hardware level, depending on what kind of hardware solution you've got in place. You can also do some traffic shaping within the port groups themselves if you need to do that. Okay, Steve asks how long ESXi will be able to know about DV switches and not able to talk with vCenter. If I am not mistaken, they will continue running until they are rebooted. While they are running, the DV switch will continue operating. We haven't gotten into DV switches, but I will in a moment. DV switch is the shorthand for a vNetwork distributed switch. The important thing to note about DV switch is that the management plane runs through vCenter server. So any changes that you want to make have to go through vCenter server. However, the data plane, the actual switching itself, still occurs on a per host basis. So traffic is switched locally on that ESXi host, but changes to that switching configuration have to come from vCenter. So if we lose vCenter server, we can't provision new VMs, and there's a workaround for that. It's been talked about, the use of something called ephemeral ports. But the basic answer is that by default, you can't provision new VMs. You can't make any changes to the configuration. It should run until it reboots, at which point it's not going to have any ability to get the configuration that it needs from vCenter server. All right. Any other questions on vNetwork standard switches before we move up to distributed switches? Okay.
No, sir, not seeing any.
Okay. So distributed switches. The key difference here, I kind of just described it, is that in a vNetwork distributed switch, we pull the control plane and we centralize it inside vCenter server. So before we had the control plane distributed, so every ESXi host had its own control plane and its own data plane, and that was why we had to make changes on every ESXi host individually. We could script that, but the changes were still occurring on a per host basis. Here in a VDS, we pull the control plane out. It's centralized inside vCenter server. The data plane remains local. What this allows us to do is do a configuration once, and then every host that is a part of that distributed switch then sees that configuration. So, for example, I can create what they call a DV port group, a distributed virtual port group. I can create that once, and if I have 10 hosts that are participating inside this distributed switch, all 10 hosts will see that DV port almost instantaneously. So you don't have to go out and do the changes 10 different times on 10 different hosts. You have to do it once, and then you're good to go. Now, you can probably easily see that there is a fairly significant benefit of that, and that is that it eliminates the possibility for configuration mismatches between hosts. Because it's certainly possible that if the port groups, if their names match, right? If vMotion is going to check to make sure it's got a matching port group at the destination end, but it doesn't check to make sure that the VLAN ID is right, or that the security settings are correct, or that the failover settings are right. It just says, does it have the same name? Yes, okay, go ahead and do a vMotion. So we could, in a standard switch configuration, we could run into situations where vMotion would succeed, and then we'd lose connectivity to the VM because port group was incorrectly configured. With the distributed switch, we eliminate that possibility because the configuration is centralized, and all the hosts participate in the same configuration. As far as capabilities go, all the capabilities of a vNetwork standard switch. In addition, vSphere 5 introduces 3 different versions of a VDS. You have a version 4 VDS, you have a version 4.1 VDS, and you have a version 5 VDS. And each of these versions has different features that it supports. So if you want all the latest and greatest features, you need to use a version 5 VDS. And that will do all the stuff like that they added in vSphere 5. So that will do NetFlow support, for example. NetFlow being a protocol that you use to transmit traffic flow information to a collector for analysis. That requires a version 5 VDS. Aside from the version-specific stuff, and that's all laid out in the networking guide, so I'll refer you there to look at the different capabilities for each one. We have the ability to do not only the same VLAN, VLAN trunks, VLAN tagging, all that kind of jazz. We have the same kind of security policies that we can set. We have multiple failover policies that we can set. They add a new failover policy on the distributed switch called load-based teaming, where it will actually distribute traffic on the physical uplinks based on the utilization of those physical uplinks. That's new to vSphere 5. So you can figure that at the DV switch level. You can say, I'm going to use load-based teaming, and then it will periodically check for the utilization of the uplinks. And if one uplink gets overloaded, it will redirect traffic to another uplink to help kind of balance out the load. We also support something called private VLANs. Private VLANs are a way of keeping machines from talking to each other when they're in the same VLAN. So consider, for example, if you had a DMZ and you had some hosts in the DMZ, and you wanted to keep those hosts from talking to each other, but you wanted them to be able to talk to, some firewall that would then allow traffic to be inside. You could use a private VLAN configuration to say, well, you guys are all on the same private VLAN, but each of you is only allowed to communicate with the upstream port, and you can't communicate with each other. So it's, among other things, it can be used in a security fashion. That is a fairly in-depth configuration. It would take us a while to talk about that, but it is supported on the vNetwork distributed switch, and you want to be sure that you're familiar with kind of what that looks like. Other capabilities. Nothing jumps to mind at the top of the virtual distributed switch, in addition to the VMware version, there's also a Cisco version, the Nexus 1000V. I don't think you'll see too much coverage of that on the VCP exam. You just need to know that it's there. Other features that are added, network I/O control, which is a more advanced form of traffic shaping. You can do inbound and outbound traffic shaping on a vNetwork distributed switch. Those are features that you can't do on a vNetwork standard switch. In the version 5 distributed switch, you get the ability to create user-defined network resource pools. Network resource pools are what network I/O control uses, and that allows you to have greater control over how traffic is prioritized using a shares and limits system, similar to what you see when you're configuring shares and limits and reservations on a per VM basis. All right, creating, deleting vNetwork distributed switches. This is done from the vSphere client connected to vCenter server. I have not found a CLI-based way of doing it other than writing a Power CLI script, and you could probably do that. I wouldn't know how, but I'm sure there's plenty of people on here that could figure out how to do that. Otherwise, it is a graphical user interface process. You go into the vSphere client, you'll go to the same configuration tab, go to the same networking section, but here to look for it, there's a button across the top that says distributed switch view, and that changes the view over to distributed switch. And that's where you can create a distributed switch. You can associate that distributed switch with one or more uplinks. You can create distributed virtual port groups, okay, which again are just like port groups in that they have a configuration with them. They have a VLAN and all that kind of jazz, okay. Just like with a vNetwork standard switch, you can control how many ports the distributed virtual switch has. So once you create the switch, you can configure it to say, I need more ports, or I need fewer ports, or I need to add more uplinks. That's all done through the same spot in the vSphere client. The key difference here, and it makes sense if you think about it, is that creating a vNetwork distributed switch on its own, that doesn't do anything. I can create the vNetwork distributed switch, I can add port groups, I can add all that jazz, but until I actually add an ESXi host into the switch, then there's no linkage there, okay? So I have to actually add the host into the switch. So the process is going to be first create the switch. When you create the switch, in the process of creating a switch, you have the option of saying, well, I want to go ahead and add one or more hosts. And if you choose to do that, then you can just do that right then. When you, let's say you want to add a host when you create the switch, you would select the host, and then it'll say, which uplinks do you want to use? And you, during the process of creating the switch, you will specify the maximum number of uplinks that you want associated, 4, 8, whatever. You can create and add up to that many physical adapters, but they'll refer to them as. And then it'll go through the process of creating a switch, adding the host into the switch, all that kind of jazz. At that point, once the switch is created, you can then add additional hosts, and it goes back to the same process again. It says you want to add host number 2. Okay, what uplinks on host number 2 do you want to use? And it goes back to that process again. This is all done inside the vSphere client. The difference here is that and this gets confusing for people. The difference is that creating the vSwitch is done on the configuration tab. You go to a particular host, and you're in. I work from memory here because I don't have the vSphere client running anywhere that I can get to. You would be under hosts and clusters, okay? And you would go to an ESXi host object and go to the configuration tab, and there you could create the, you would see, or you could create the virtual switch. But there's also another view. If you go to the inventory view and go to networking, then you will see your virtual switch there. You can also create a distributed virtual switch there, and you can add hosts to the distributed virtual switch there as well. So 2 different views here that you can look at. And some things you can do in both places. Some things you can only do in one place. So if you have the opportunity before you get the exam, just familiarize yourself with the configuration tab on a pros basis and then the networking view for a distributed virtual switch there. All right, I'll take a couple of quick questions here before we go into port groups and virtual adapters. Steve asked preference about putting VM kernel ports on the DB switch. I don't have any major concerns putting VM kernel ports on the DB switch. Whether or not I would do management on the DB switch depends on my environment and what it looks like. That would be a kind of a broader design question, but no real concerns on my end about using VM kernel ports on a distributed virtual switch. All right, let's see. Stacy asks, version 4.1 DDS, possible to do inbound, outbound network I/O control. You can do network I/O control on the 4.1 distributed virtual switch. What you couldn't do on the 4.1 distributed virtual switch is you couldn't create user-defined network resource pools. So you just had the resource pools that were predefined. You had no way of creating your own network resource pool and assigning your own shares and values to that and associating that with a virtual machine port group or other types of traffic. That functionality was added in 5.0.
And Scott, I've got another question here from Chris. He wants to know if you can port mirror across hosts with distributed virtual switches.
Port mirror, you can do NetFlow support to export the traffic statistics. Port mirroring is certainly a function of the 1000V. I don't believe that it's a function of the VMware distributed virtual switch, although I could be mistaken. So I don't think that you can do the mirroring, port mirroring on the standard, even the 5.0V switch. I'll have to double check on that, but I think that port mirroring functionality is something that they kept in the 1000V. They didn't add it to the VMware distributed switch. So you can do NetFlow support, but I don't think you can do any mirroring. Any other questions?
Josh Cohen, so Alexander tossed a link here into the questions about how to do port mirroring on a VDS. Josh Cohen says that you can do it on a VDS, so there may be some additional information out there. I'm going to go ahead and put the link. I think actually our good friend Mr. Jason Nash from Vero wrote a blog post about it, so go ahead and put it here into chat. And everyone in chat, go ahead and take a look at that. And Scott, I guess go ahead and move forward, please.
Sounds good. And keep the information coming, guys. You know, if I miss a piece of information, then by all means correct me. So, all right, adding and removing hosts, we covered that. Adding and removing DD port groups, again, same sort of scenario here. You're going to have VM kernel ports. You create VM kernel ports the same way, although here they're referred to as virtual adapters. So they had to change the name to throw you off. So if you need to create a VM kernel port on a distributed virtual switch, you will actually create a virtual adapter, and then that virtual adapter would be then associated with management traffic or fault tolerance or vMotion or iSCSI traffic or whatever, or SDE, whatever it is you're doing, right? And then DD port groups will be your virtual machine ports, where you would go in and apply this configuration to the group of virtual machine ports, and that would include stuff like VLAN configuration, security configuration, anything of that nature. And just making sure I got that here. Okay. Same sort of process. It's a wizard-driven process inside the vSphere client that you go through and you say, I'm going to create a new virtual machine port group, and it'll prompt you for what type of configuration you want, whether you want an access port, in which case it's just going to say, you know, I'm in a VLAN, I don't use trunks or anything, whether I'm going to do a VLAN trunk or then specify the range of VLANs. It's a little counterintuitive here, because what you're doing when you create that is you're saying the VMs in this port group have this functionality. So if you're saying I'm going to create a port group, let's say I've got a VLAN trunk coming in from the physical switch, and on that VLAN trunk I'm passing VLANs, 100 through 200. Okay. When I go and create the DB port group, if I want this DB port group to be associated with VLAN 100, I actually will set that as an access, and then put in the VLAN. I'll put that as an access port and put in the VLAN ID. The only time you would choose VLAN trunk is if you want to pass those VLAN tags up to the guest, and then you can specify a range of tags that you want to pass up to the guest. So that's the difference between how you would pass tags up to the guest in a standard switch where we use the 4095 versus a distributed switch where we actually specify that this port group is a VLAN trunk port group, and then we specify the range of VLAN IDs that we want to pass up. And you can also have a private VLAN, which is a separate configuration as well if you wanted to create a DV port group that corresponds to a private VLAN. That's all done there. Then you'll go through and it's a wizard-based process. It's really straightforward. Creating and removing virtual adapters. Again, this is where you create your VM kernel ports. And VM kernel ports serve the same function as they do with a standard switch. So this is, again, where you're going to do management. If you want to run management on a DV switch, iSCSI, FCOE, if you're using software FCOE, fault tolerance and vMotion. Now, the real trick is how do we get things from one to the other, right? Now, you could do it yourself. You could just, let's say you started out with a standard switch and you're going to migrate into a distributed switch, and you want to move your vMotion over, and you want to move iSCSI over, and you want to move all your VMs over, right? You certainly could do it yourself. The trick, of course, is to make sure, if you want to avoid the outage, is to make sure that you've got uplinks working on the standard switch, you've got uplinks working on the distributed switch, and you've got the appropriate configuration for a port group on the standard and the distributed. At that point, migrating a virtual machine is just as simple as going into the properties of the virtual machine and changing the network connection from, whatever it's called. Let's say your vNetwork standard switch had a port group called blue, and then your distributed had a port group called red. You just open up the properties for the VM, change it from blue to red, click OK, bam, done. Now that's fine if you only need to migrate 1 or 2 or 5 or 10. If you need to migrate 100, that gets time consuming. Now, I saw Josh Atwell saying he was going to make me a Power CLI master, so I'll put it to him to say you could write a Power CLI script that would do that for you, right? Or there is a migration tool built into the vSphere client that lets you migrate virtual machines both to or from a vNetwork distributed switch. So it makes it easy the process of going and say, basically the way this wizard works is you'll choose your source and you'll say, I want all the VMs that are attached to the port group blue. And it'll go through the vCenter and find all the VMs that are attached to the port group named blue. And I want all of these to be changed to the port group named red. And you click OK, and it just bam, 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 through the whole list and migrates all of them all at once, right? Same thing, if you need to go from a distributed switch back to a standard switch, you could say start me at red, which is a distributed port group, move me to blue, which is a standard port group, and you could do that too. Okay? And what it's doing is it's just going in and modifying the properties of the VM to change that piece. So it's possible you'll see a brief outage, but if your connectivity is already pretty good, you've already tested the switch on both sides, everything's fine, and the configuration is good, the outage should be minimal and probably not even noticeable to the end users in most cases. Virtual adapters are a little more work. You could delete them manually and then recreate them manually. That's certainly one method. It would get tiresome, to put it lightly. So there is also a method to migrate virtual adapters to or from a vNetwork standard switch. And I think this went back to the question somebody had earlier about what does it look like? How do I migrate from a vNetwork standard switch into a vNetwork distributed switch when I have one uplink here and one uplink there? The process is going to depend on how many uplinks you have in your host. Worst case scenario, you've got 2 uplinks. Let's say you're running in a 10 gig environment and you've got 2 10 gig ports, because honestly, most people can't afford to have more than 2. In that particular case, what you have to do is you have to swing one of those uplinks over to the distributed switch. So you've got one uplink on your standard, one uplink on your distributed. Okay. You can then use either the VM migration tool, or you can go into the configuration tab and migrate virtual adapters. There'll be a blue hyperlink to that that says migrate. They have one that says migrate physical adapters, and they have one manage physical adapters, and they have one that says manage virtual adapters. And when you go into that manage virtual adapters, you can migrate from the standard switch where it is, across one uplink, over to the distributed switch over the other uplink. You just have to make sure that your configuration matches on both sides so that you don't inadvertently cause yourself to lose management connectivity or anything of that nature. I have run into people who run into issues migrating the management VM kernel interface using this process. I've also run into people who have done it successfully. Just be aware that if you run into a problem with your management, right, this is how we get connectivity. This is how vCenter talks to the ESXi host. So if in the process of migrating the management network from standard to distributed, you somehow lose, vCenter is not going to be able to help you, because vCenter needs to go talk across the network to the host, and it's that process of talking across the network that's now host. What you have to do in that case is you have to go to the host console, you have to use the VCUI, and there's an option inside the VCUI that says recover management network, something along those lines. I don't remember the exact wording. But what that does is it recreates a standard switch, vSwitch 0. It recreates a VM kernel port, and it associates management with that VM kernel port. So it basically kind of, if you get messed up and you can't get on the network to fix it, you can go to the VCUI on the console of the ESXi host and kind of reset management back to its default setting. And then management, again, goes both ways. We can, the migration goes both ways. We can migrate VM to and from, and migrate virtual adapters to and from. All right, let me stop for questions here. Okay, there's the link on Port Marion. Very good. Source-based Mac load balancing IPS. I am going to get to that in just a moment. I know we're running a little bit over, so if you can stick around, Ray, we're going to talk about that. Okay, Josh pointing out the wizard works with the Nexus 1000V also. Very good, thank you. Damien, is Josh unmuted?
Yeah, I just unmuted him.
Okay, Josh, did you want to jump in on the management of VMK stuff real quick?
Yeah, I can speak just real quick on that. Last month, I was involved in developing a process at work for migrating clusters that were hosted by Nexus 1000V between virtual center servers. It was a very interesting process. But there are wizards for, as you were mentioning, migrating the VM kernel ports. Those do migrate directly without issue. We didn't lose any connectivity, but there is one caveat. If you are running NFS storage and you have static routes assigned, you will lose those static routes. We verified with VMware that this is intended and by design, but you will lose any static routes, and the only way we, well, I guess the way we recovered was using ESXconfig-R, or ESXconfig-route, and then -R for the restore. And you just have to make sure you do that very quickly, because the timeout is, relatively short.
Sure, that's interesting about the restore. I've never used that before. Didn't that still say like internal use only or something?
Yeah, it's internal use only, but it's the only way that you can restore those routes in the amount of time needed to make sure that you don't have any timeout in your connections to your NFS storage. And we did not test it without using static routes, because within our environment we have to use static routes. But the first time we went through the process, it was an issue. I hate to say, fortunately it was a non-prod with very few things there, but yeah, it was challenging. But the migration of all other VM kernel connections was very smooth, and it does use a slightly different wizard for that, but it does work very well.
Excellent. Okay, good deal. Thanks, Josh. I appreciate the information. All right, so let's talk real quick about the use cases here, and then we'll move on to our last one and move through this. We've covered a lot of the stuff in the last objective already, so we'll just kind of review some of this stuff. Use case for vNetwork distributed switches. This, again, kind of already talked about this because we looked at the use cases for the vNetwork standard switches, but anywhere where you say, hey, I want to be able to define a VLAN or port group once and have all the hosts participating in that switch, automatically see that configuration. If there are features or functionality that you need in the distributed switch that you can't get out of the standard switch, for example, if you needed private VLANs, then that would be an instance where you would have to step up to using a vNetwork distributed switch. Similarly, if you had requirements for being able to restrict the range of tags that get passed up to a guest. That's something you can do on a distributed switch that you can't do on a standard switch. If you needed network I/O control, for example, that's a distributed switch functionality. If you needed inbound and outbound traffic shaping, that's a VNet or distributed switch piece, right? So just keep that in mind as you're looking at this. As always, I talk about this when I talk about design issues. Just understand the relationships between the different components here. Recognize that you are introducing a management plane or a control plane dependency on vCenter server. And back to our discussion earlier about what happens if vCenter goes away, what happens if VNet distributed switches. You may find yourself in a situation where you can't make any changes to the networking because vCenter is unavailable. Now, hopefully in your design you've taken the time to properly protect vCenter and all that kind of jazz. But just understand the impact and the effect that it will have on the rest of the design as you move through either of these choices. I mean, it's not to say that a VNet or distributed switch is worse than a standard switch, but just to say that they have a different set of impacts and a different set of ways they affect the rest of the design. So be aware of those as you move forward. Damien, you got any other questions before we move on?
Let's see. No, not really. Ray, kind of had a point to something that Jason Bhakta was kind of talking about in general chat about using multiple management networks and to migrate one at a time and verify as you go, to kind of avoid host outages. So yeah, outside of that, let me do a quick check on Twitter. Nope, looks like we're good.
Okay, so let's look into the last objective here and talk about these. Again, a lot of these we've touched on already because it's just kind of the nature as you talk about the V-switches, you get into this stuff. So the third objective in the section 2 of the VCP5 blueprint is configure vNetwork standard switch and vNetwork distributed switch policies. So first, identifying common policies. Common policies would include stuff like your NIC failover order, which again you can set at a vSwitch level as well as at a port group or DV port group level. The exception being route based on IP hash. And I know Ray had wanted us to go into that in a little bit more detail, so 2 more bullets, Ray, and then we're there. So that would be one policy, would be your failover policy, your load balancing policy, your security policy. This is where you would allow permissionless mode, other things. Those are all set both on the vNetwork standard switch and the vNetwork distributed switch. And in some cases, those can be set both at the switch level and at the port group level. So you can have a default setting that a port group could inherit from the switch, or you could have a port group override the default setting and have its own specific setting in some cases. The other thing we have is the ability in a DV port to actually block ports. Now, I'd love to hear feedback on when you might want to do this, but the idea here is that you can actually go into a port group and you can block all the ports in that port group, basically severing network connectivity with a single blow to all the VMs that are attached to that DV port group. That's, again, a distributed virtual switch feature, so it doesn't apply to the vNetwork standard switch. Load balancing and failover policies. All right. So we've been talking a little about this. There's a few different policies, right? We have route based on originating virtual port ID, route based on source mask hash, route based on IP hash. We have explicit failover, and then we have load-based keying. And those 5 are the ones that are available in a version 5 distributed vSwitch. Okay? If you're using a vNetwork standard switch, you get explicit failover, route based on originating virtual port ID, route based on source mask hash, and route based on IP hash. Which of these should you use and why? Let's look at how they work real quick. And again, I apologize that we're running over. Hopefully this is useful information for you guys. Route based on originating virtual port ID is better described as pinning. So if you've worked in the physical networking space, like with the Nexus family of fabric extenders or anything of that nature, and I think there's even a pinning feature inside the Nexus 1000V that's called pinning. But what this does is when a VM comes online, it is pinned to a particular uplink. And then it will always use that uplink until that uplink goes down. If that uplink goes down, it will then be repinned to another available uplink. and it will stay on that uplink until it goes down, and then it will, so on and so forth. The key thing to note here is that when it's pinned to that uplink, if the, let's say it's pinned to VMNIC 0, and you also have VMNIC 1, they're both configured uplinks on this particular switch, which could be a standard switch or a distributed switch, and you have the setting, the default settings, and route based on originating virtual port ID. VMNIC 0 goes down. All the VMs that are on VMNIC 0 that are pinned to that port now fail over to VMNIC 1, unless you've configured that as to be, not used at all. Normally you wouldn't do that, but if it's configured as active or standby, then you'll just fail over to VMNIC 1. When VMNIC 0 comes back online, depending on your configuration, in many cases, those VMs are not going to dynamically rebalance to VMNIC 0. They're going to stay where they were. So the kind of the potential drawback, if you will, with route-based on originating virtual port ID is that you could run into a situation where you have VMs all ganging up on one uplink, and because they're pinned to that uplink, they're not going to dynamically change. Okay. The answer for that in many people's minds is route-based on IP hash. And what it does in that case is that it will look at the source IP address of the VM that's communicating. It will look at the destination IP address of the VM that's communicating. It will perform a mathematical calculation on those IP addresses. It will come up with a value. The value will range from 1 or 0 to the number of uplinks that the switch has. So if the switch has 4 uplinks, mathematical calculation will come back with 0, 1, 2, 3. So I have 4 values ranging from 0 to 3. If you had 8 uplinks, you would get values come back from 0 to 7. If you had 2 uplinks, you would get back a 0 or a 1. Based on the result of that mathematical calculation, the traffic for that source IP and that destination IP will then go out whichever uplink is identified by the value. So if it comes up with a 0, it goes out the first uplink. If it comes up with a 1, it goes out the second. If it comes up with a 2, it goes out the third. If it comes up with a 3, it goes out the fourth. It's assuming you have 4 uplinks. And it does that calculation basically on a per flow basis. So every pair of source and destination IP addresses, it runs that calculation and figures out which link in the group it should use. It doesn't ever recalculate, and even if it did recalculate once it's in a flow, the math is always going to be the same. So the important thing to note is that even though a route-based on IP hash will end up potentially allowing multiple conversations to be spread across multiple links, any one conversation will never be able to use more than one uplink, period. That's just how it works, right? So very, very common, people will use route-based on IP hash when they're using IP-based storage, especially NFS. So say I'm going to create 4 uplinks, and I'm going to bond them together, and I'm going to send them all to this this NFS data store, which has an IP address associated with it. You will never be able to use all 4 of those uplinks as long as that NFS data store has only a single IP address associated with it, right? Because the math is always going to be the same. It's always going to be the same source and destination. The source is going to be a VM kernel port. The destination is going to be the IP address on the NFS export. No matter how you do it, the math is always going to have the same value, and you're always going to use the same uplink, unless it goes down, in which case you'll then use one of the others. So that's very important to understand, is that traffic flows in a route-based and IP hash configuration an individual traffic flow cannot use more than one uplink. Multiple flows will be spread across multiple uplinks. If your traffic is primarily one-to-one, one VM to another system, route-based on IP hash doesn't really help you much. If your traffic is one-to-many or many-to-one, then route-based on IP hash can help. Route-based on math hash, route-based on source math hash, simply does a calculation on the MAC address of the source VM and then assigns it to a uplink based on that hash. That's it. It doesn't really offer any real benefit over route-based on originating virtual port ID, in my view, because either way, it's going to assign it to an uplink. The only difference would be that it may potentially result in a more even distribution of VMs across the available uplinks. Pinning, it just basically starts with the first one. It says bam, 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 and just kind of round robins across the assignment. Whereas the route-based on source MAC hash might result in a more even distribution. but it doesn't do any sort of dynamic load balancing, anything of that nature. Okay? Route based on IP hash requires switch configuration, physical switch configuration, because what's going to happen is a physical switch is going to see MAC addresses on multiple ports, and unless it's been configured ahead of time to expect to see MAC addresses on multiple ports, you're going to totally wig it out. So you have, when you do route based on IP hash, you have to do configuration on the physical switch side and configuration on the vSwitch side. So that can make it difficult to configure sometimes. In vSphere 5 with the distributed virtual switch, a version 5 distributed virtual switch, you can do load-based teaming. Actually, I think you can do that in the 4.1 version as well as the 5.0 version. Okay? That is where it actually will go and it will look at the utilization of the uplinks and then place traffic from a VM on an uplink based on utilization. The attempt being to keep the utilization even across all of the uplinks. Okay. Again, that's a DD switch feature. It's not available on a standard switch. It does require version 4.1 or version 5.0 distributed virtual switch. So hopefully, Ray, that will help you with your concern on which ones we should use and the differences. Okay. Question here that's applicable, I think, from Steve Beaver. If you want to have the PNIC split at 2 different switches, you still need MAC-based without LAC-P. That depends on the upstream physical switches. If the switches support something called multi-chassis ether channel or virtual port channel, then you could do a link aggregation across 2 upstream physical switches. Okay, in a Nexus 5000, 5500, Nexus 7000 environment, we can do virtual port channel. In a Nexus 2K environment, we can do a virtual port channel. Cisco like 3750 support multi-chassis ether channel, although I think they have to be stacked. So that depends on the upstream switch. Aside from that multi-chassis ether channel or virtual port channel support, you're absolutely right. If you want the PNIC to go to separate upstream switches, which you would want to happen, otherwise you're introducing a single point of failure in your design, then you have to forego the route based on IP hash setting. That's important to note. All right, VLAN settings. Failover policies. We're going to talk about failover policies real quick. Failover policies, there's another load balancing option which is called explicit failover. That goes down to a dialog box just, or a partial dialog box just below that, where you can specify the order in which you want NICs to be used. Okay? And you have options of specifying a NIC to be active, a NIC to be standby, or a NIC to be not used. If it's active, then it will, the vSwitch will actively use it. It will assign it in route based on IP hash and originating virtual port IDs, for MAC hash, all that kind of stuff. If it's standby, it's only going to be used if another NIC fails. All right? And then if it's not used, it will obviously not be used. Those failover orders can affect a variety of things. Okay? They're honored for everything pretty much except for route based on IP hash. Route based on IP hash, you have to be careful how you combine failover orders and standby NICs and not use NICs, that kind of thing, because the switch needs to know which ports it could possibly see MAC addresses on. So you generally don't want to combine like 2 active ports and 2 standby ports and have them kind of mix or whatever when you're doing route based on IP hash. So again, another reason why IP hash can be problematic in some configurations. Again, we talked earlier about how you can use failover policies to do some rudimentary kind of traffic direction, saying I want this port group to preferentially use this NIC, this port group to preferentially use this NIC. In the event of a failure, they still get redundancy. You do want to be careful about QoS and thing in that environment, depending on the traffic that you're coming with. VLAN settings, we've pretty much already covered those already. You know that you can specify a VLAN ID to associate that to enable it to that 1 key tag. We know that we can pass VLAN tags all the way up into the guest on a standard switch. We support 95. On a distributed switch, we specify VLAN trunk and range. We know we can do private VLANs on a distributed switch, so that's all good. Traffic shaping on a standard switch is outbound only, okay? And on a distributed switch, you get both, on some versions, you get both inbound and outbound shaping. If you're going to deploy something like the Nexus 1000V, and you also have a Cisco-based physical network, then you could apply some QoS settings there. Don't think you'd see that on the VCP5 exam, but just so that you guys know, that information may prove useful as well. You can create some end-to-end QoS settings because you've got a Cisco set of markings all the way through. Traffic statement policies are done both on the vSwitch level as well as on the port group level. So you can have a default setting that affects the entire vSwitch and that other port groups inherit, and you can have per port group settings. TCP segmentation offload support for virtual machines is something you can configure. To be honest with you guys, I have no idea. I don't remember where this is. So if anybody's got any information they want to add in the chat to share with everybody else, that'd be great. So I haven't taken my VCP5 yet, so I'm studying just like you guys are. Jumbo frames.
Wait. You haven't taken your VCP5?
No, I'm too busy traveling, man.
How did you get on this podcast?
I don't know. Some guy named Damien invited me. I don't know. That's slow, you know?
I think you're more than qualified, Mr. BCDX.
Well, you know, hey, I gotta study the details just like everybody else, so that's fine.
Yeah,
this is actually very helpful. Preparing to talk to you guys has actually been very helpful. So, any case, so yeah, by all means, speak up in the Q&A or in the chat if you have the information that's specific to the TSO, TCP segmentation offload. The idea being there that you can offload some of the processing for TCP segments to the hypervisor rather than having to process that, or to the NIC, rather than having to process that in the hypervisor or in the guest OS. Jumbo frames, we talked about a little bit. A jumbo frame is any frame over 15, with an MTU, with the maximum transmission unit, over 1,500. Generally speaking, when we say jumbo frames, most people will say that they'll say jumbo frames when they mean a frame size of approximately 9,000. The maximum, I believe, is 9124, or right in that range. So people set that to around 9,000. That would be considered a jumbo frame. The important thing to remember here is if you enable jumbo frames, there's multiple places where you have to enable it. Okay, you have to enable it at the vSwitch or DV switch level. They did add a GUI option for that, so you don't have to go into the command line. Well, you can. That would be done using VSX config-vSwitch or VI config-vSwitch from the VNA. You have to enable it there. It has to be enabled at the physical switch layer, and the process for enabling at the physical switch layer will depend on the switch. I've written a couple of blog articles on that for various pieces, like on a Catalyst 3560 or 3650, it's done one way. On a Nexus 5000, it's done another way. So just be aware that you have to enable it at the physical switch layer, and then all the hosts on either end need to support that feature as well. There may also be, if you want to enable that within the guest OS, there may also be guest OS things that you have to do in order to enable jumbo frames. If you don't get jumbo frame support working on all the levels, you'll see some very odd things happen. For example, I had a situation where jumbo frames were enabled on the storage side for an NFS server, but not enabled on the client side, on the ESXi hosts. And so you could mount the data store and it would work. But when you went to browse the data store, because we had more data traversing the network at that point, then the NFS server would send a jumbo class frame, which of course would never make it to the host, and so it would just hang. So it looked like it was working because you could mount the data store, but you couldn't do anything with the data store because once you got past the initial mounting process, then things stopped working. So just make sure that you enable jumbo frame at the guest OS level if you're going to use it there, at the port group level, at the vSwitch level. If you want jumbo frames on your VM kernel ports or your virtual adapters, you have to enable them there as well. At the physical layer, and if you're doing jumbo frames on the storage side, which is fairly common, then make sure you enable it at the storage array as well. Interesting little side note here, if you're doing FCOE, FCOE uses something called mini jumbo frame, which is kind of an oxymoron, a mini jumbo frame. But you don't have to configure that. It's all done automatically for you at the network layer. So even if you're doing the software FCOE initiator inside vSphere, when you go and create that piece and you add the FCOE initiator, it takes care of the appropriate configuration as needed there. And you don't have to do anything at the, generally speaking, you don't have to do anything at the physical switch layer. All right, last piece, and then we'll open up for final Q&A. Determine appropriate VLAN configuration. We've been back and forth on VLAN configuration, so I think we've done quite a bit here. Again, just understand, it is important, I think, to make sure you guys understand the behavior of the native VLAN, because remember that VLAN is untagged. So if you want the native VLAN to be recognized by a port group, then you don't put a VLAN ID value for that port group. You do it blank, because blank means untagged. So native VLAN is untagged. That means it's a blank. It's not a. If your native VLAN is 1, and you go in and you put 1 in the VLAN ID on the vSwitch, it's not going to work, because vSwitch says I look for a tag that says 1, and the native VLAN is coming in untagged. So that's an important distinction to make. Otherwise, it's just a matter of determining, is my physical switch layer, am I getting VLAN trunks? Are the right VLANs being passed across? Then do I have the right VLAN IDs being associated with my port groups? Do I have the port groups defined correctly? That kind of stuff. And then the only one we haven't really talked about in detail would be private VLANs. That's a fairly in-depth topic, and I'm happy to come back if you guys want to get into that, but it's a fairly niche thing as well. You don't see it a lot. The documentation does a good job of describing how it works. Basic idea is that you're going to have two VLAN values. One will be the kind of the downstream VLAN, and one will be the upstream VLAN. And traffic can flow downstream to upstream, but it can't flow downstream to downstream. That keeps hosts from talking to each other inside a private VLAN configuration, depending on the details. There's some ways you can work around that as well. And again, each of those are implemented in different ways. You can only do private VLANs on a distributed switch, and then if you're doing VLANs on a standard switch, or if you're doing VLANs all the way up to the guest on a standard switch, it's done one way, done differently on a distributed switch. All right, and that wraps up the material that I have, so let's take some questions. All right, Stacy asks about load-based teaming with network I/O control on 10 gig versus sucked-in partitioning. It's out of scope, yeah, it is. But an interesting discussion nevertheless. I had this discussion with a customer yesterday, actually. There was some discussion about whether we should do the partitioning in the hardware, which you can do using Flex 10 or you could do using UCS VIC, or whether they should use network I/O control. Both approaches are equally valid. Both approaches will have their pluses and minuses. It's really something that you have to kind of get down and look at it within your specific environment. A lot of it will depend on the operational characteristics of your environment. If you've got a really strong network team, they may, and depending on how your environment looks, they may prefer doing it in a way that's conducive to the network team. For example, they may say, we want you to use the network 1000D, the Nexus 1000D, and to use some QoS inside the 1000D, rather than doing hardware partitioning inside a Flex 10 or a UCS VIC. But both are good options. Either are valid. That's probably more of a design decision based on criteria and requirements than a technical one. So good question, Ms. Okay, Alexander points out that sometimes he hears the term baby jumbo, as opposed to mini jumbo. So yeah, both are there. FSUE needs QoF enabled. That depends on your environment. So you just have to look at your particular environment. Hardware FCOE will enable QoS at a level that you don't configure, generally speaking. The software FCOE, I don't think that it actually enforces QoS or traffic shaping, but you would want to be careful about how you do that if you're doing the software FCOE initiator across the same 10 gig mix that you're running on the traffic. So just be aware of that. Ray points out a quick way to do a test for jumbo frames is to do a ping and specify the ping size of 9,000 and also prevent fragmentation, which ensures that the ping will send the entire packet across without fragmenting it. So yes, that's absolutely true. Thanks, Ray. Untagged, you can also use the VLAN ID 0 or distributed blank, so you're right there. Absolutely, Alexander. and then throwing from tag to untag shows up as 0. And then Ray gives us, Damien, you might want to take this command that Ray mentioned about the ping piece and actually put that into chat if everyone else can. It gives actual syntax for doing a ping test to verify jumbo frame size end-to-end. So,
Okay, we'll do.
Okay. Tim has a question on IP hash. Tim, you want to just speak up and answer that question so everybody can hear?
Yeah. I was playing around with something in NonProd Lab this weekend. I've got backend NFS storage. I've got a cluster of 3 hosts. The uplink ports on my NFS kernel ports are not ether channeled. I have 2 NICs. Whoever set it up prior was just using source IP load balancing. I was overloading one of the NICs, so I decided to play around with enabling IP hash. I enabled it. Not sure why it's working on one of the hosts, since I thought ether channel was a prereq, and they're not ether channeled. But it works on one and not on the other 2, and the hosts are absolutely 100% identically configured.
Well, there would be a difference in the configuration, and that is the source IP address is different because you got a different VM kernel port, right? So I would.
Therein lies the only difference, though. The backend ports on the NetApp, same FQDNs, which resolve to the same addresses. Single VM kernel port for NFS. All the storage is configured identically. All the networking, switching, everything is configured identically. I mean, even to the point where at the Cisco layer, we did a copy and paste on the ports just to verify that wasn't an issue.
Right. I would wager that it's and this is a complete guess. So I have run into issues where I've seen this occur. It wasn't recently. It's been a while since I saw it, but yeah, I have seen this occur. My guess would be that it's just a matter of the hashing coming out different, and that in one particular case it's coming out on one port, and therefore the switch isn't getting completely freaked out. On the others, it's coming out a different port, and that's causing the switch to kind of like, whoa, hold on a second here. So that could certainly be part of it. But you are correct. Generally speaking, you do need to go in and set up the ether channel on the switch first.
Okay. All right. Yeah, I was just curious as to why it was working on one and not the others.
Yeah, I have seen that happen. It doesn't happen often, but I have seen it happen in my own non-prod environment, and I wasn't able to come to a hard and fast. This is why it works, or this is why it doesn't. If you were geeky enough and really wanted to, you could actually go and do the XOR calculation against the IP addresses and see what the values came out to be, and see if they came out to be different, right? Which might lead you to say that traffic is going on one uplink on the host that's working and on a different uplink on the host that's not.
That's even too geeky for me at 9:30 on a Wednesday night.
That's true, but still, that's how you would go. All right, Damien, you got any other questions coming up?
Yes, sir. Ray had one more question. I just assigned it to you.
Okay, should I see it in here somewhere? Oh, there it is. Okay. Intra-host traffic to route to your core switching for introspection. Can you first hook it up with a standard? Yes. You want intra-host traffic to route to the core for inspection. So this would be if you wanted traffic from one VM to another VM to go through some core infrastructure. Can you do that? If they are on the same, if they're in the same port group, which means they're in the same, essentially the same broadcast domain, if you will. Aside from doing some ACLs like on the Nexus 1000V or something, there's no way, or a private VLAN. You could do a private VLAN. That would be the only way that I would see being able to keep 2 VMs from talking to each other on the same host and the same vSwitch. Now, if they were on 2 different vSwitches, even on the same VLAN, like you had a port group on vSwitch 1 that was configured with a VLAN ID and a port group on vSwitch 2 that was configured with the same VLAN, they wouldn't be able to talk to each other because there's no vSwitch to vSwitch communication. They would have to go out and uplink, and then the network, the physical network would have to do something and then potentially bring it back again. So that would be one way of doing it. You could potentially use a private VLAN configuration, which is the same sort of thing. Potentially, if you're using the 1000V, you could create some per-port ACLs that might force that. You could send copies of traffic out using port mirroring or anything of that nature. But actually forcing the traffic through, you would have to do private VLANs or separate layer 3 domains or separate vSwitches. Or if anybody has any other ideas, feel free to speak up.
No, I'm seeing PVLANs as the only answer here. Well, actually, Josh Cohen wants to know if you could use vShield Suite for that.
Oh, yeah. Yeah, that's a good point. We could potentially use vShield app to do that. I think vShield app would be the most appropriate solution in that particular case. So we could do that. I don't think Zones or Edge would help out there, but vShield app could probably do it for you. So that would be another way of doing it, which is essentially, you know, and honestly, for that matter, we could probably do it with, again, getting really geeky here, we could probably do it with some sort of, you know, transparent layer 2 firewall running as a VM and it having to see all the traffic going through it. But again, that's kind of an edge, you know, case, not something real mainstream. So there's a couple different ways we could do that, but it's going to require a few jumping through a few hoops. Good point. Thanks for bringing that up, Josh. All right,
wow.
So that's all I have, Damian.
Wow, you know what? Actually, this kind of reminds me a little bit of when we had Andre Libovici on last year to talk about DDI. It was like a breakneck, it was a breakneck 2-hour deep dive on Vue, and I felt like I got hit by a truck full of like books or something after that. It was just, wow. My brain can't process all of that. So thank you very much, Scott. I think you've done an awesome job tonight, and based on the feedback from the chat as well as Twitter, I think everyone's been extremely happy. So just kind of a joke here. There's a question going in chat is, you know, who do you ask if there's a question that you can't answer?
Oh, well, you know, I mean, I tell people when I go out and talk to them all the time, if you're trying to play stump the chump, you won't have any difficulty there. There's lots of information that has fallen out of this leaky organic matter in my head. You know, go ask Jason Baki. He probably knows.
Yeah, absolutely. And speaking of Jason Baki, we're actually going to have Jason on next week on the Brown Bag, Wednesday night, 7 p.m. Central, to talk about Section 4 of the VMware VCP5 blueprint. So I'm pretty stoked. Jason's a great friend of the show. He's a regular attender. He's a regular presenter, and so really looking forward to that. And Scott, honestly, man, thank you very, very much for your time and for you know, all the knowledge that you brought tonight. It's been greatly appreciated.
My pleasure, Damien, and thanks to you and to everyone who has joined us tonight. I hope the information has been useful. I am happy to help support the community, and so I appreciate the opportunity.
Yes, sir, absolutely. And everyone who's listening right now on the call, this will be available for download on professionalvmware.com. I usually link to Professional VMware via my blog at damiencarlson.com. Scott is available on Twitter. He is at Scott_Lowe, L-O-W-E. You can also check out his blog at blog.scottlowe.org. Is that right, Scott?
That is correct. Yep.
Okay, cool. And as well as all of our podcast and iTunes feeds, they're at bit.ly/brownbag iTunes and bit.ly/brownbag podcast. So looking forward to talking to everybody next Wednesday night with Jason Bocci on Section 4. Thank you very much. Have a great night. Talk to you guys in a little bit.